Yes, good evening. In this class, I'm teaching to you some of the circuits related to the resistance series and parallel combination. Okay, now it's very clear that, as you know well, if the current is moving uh, in the same path without deviation, that is nothing but series combination of resistors. If the current is dividing in number of branches, then those resistors are in parallel combination. Okay, in series combination, the current remains the same. In parallel combination, the potential difference remains same. Remember carefully. In series combination, which is same current passing through the resistors. In parallel combination, which is same, the potential difference across the resistors remain same. Now, this is a circuit I considered on the board, right? So now this circuit straight away is not a solution. From this here, we are taking or we are simplifying the circuit in a easiest way. That easiest way is nothing but in the circuit at first observe the cell. To solve like these type of circuits, at first where is the cell? We need to observe. Here this is the position of the cell. To the cell, if the any resistor is connected, so this resistor 10 ohm is connected to the negative terminal of the cell. It means what? It means here this 10 ohm resistor is in series combination. Now it means, listen carefully, ma. To the cell, this 10 ohm resistor is in series combination. Now I am allocating this as like this. Observe carefully. This is a cell I consider here. Negative terminal of the cell is connected to 10 ohm resistor. 10 ohm resistor, and this is 10 ohm. This is 10 ohm. And now here we are considering the current is coming in this direction, and this is a negative terminal. The current is moving like this. So here what's happening? What's happening here? From here the current is coming to this point, right? So now, and here also positive terminal, no? Positive terminal. So here bifurcation takes place. Through this some current, is passing, and from here the current is moving in this direction. So from here, and from here, all the currents are moving towards the negative terminal of the cell. Listen carefully. Where the current is dividing, then those resistors are in parallel combination. Now this 10 ohm and this is the resistance which we consider as 5 ohm. This 10 ohm and 5 ohm. Why? Because here, from here the current is coming and from here the current is coming. Both the currents are meeting at this point. It means the division of current takes place at this point, and thereby from here the division of the current. For example, the main current is I, here I1 and here I2. So this at this point I1 and I2 considered nothing but the currents are dividing in multiple branches. When the currents are dividing, then we used to say that these two resistors are in parallel combination. Now here I am taking that to the cell, this 10 ohm resistance as well as 5 ohm resistance. This is the 10 ohm and this is the 5 ohm, and both are in parallel combination. And then come across this. Now, observe carefully. In the diagram, they mentioned this is the point A and this is the point B. This is the point A and this is the point B. Okay, so the two resistors 5 ohm and 20 ohm, whatever you considered, this 5 ohm, for example, the current is moving like this. Whatever the current is moving through this 20 ohm resistance. Why? Because this is towards the positive terminal side, and that's why I'm starting from here. Whatever the current is passing through this 20 ohm resistance, the same current is passing through the 5 ohm resistance also. It means 20 ohm and 5 ohm. If the currents passing through the resistors remain same, the currents passing through the resistors remain same, then we used to say that those two resistors are in series combination. Okay, now, so this 20 ohm and 5 ohm, both the resistors are in series combination. See, thereby what happens? We need to add these two resistances, 20 and 5. We need to add. So 20 plus 5. Why? Because both the resistors are in series combination. Got it? Now, so the 25 ohm resistance is in parallel to this 10 ohm and 5 ohm. Why? Because the circuit starts from here. The circuit starts from here. So here, when the circuit starts from here to this part of the circuit, again this 25 ohm resistance is in parallel. So that's why here we are taking that 25 ohm mentioned like this. Now all these are connected like this. So it means 10 ohm, 5 ohm and 25 ohm. All these are in parallel. Okay, this entire part is in series to the 10 ohm. So at first I am taking that. R. This is I am taking it as Rp is equal to these three resistors 10 ohm, 5 ohm and 25 ohm. All these three are in parallel. So that's why this I am taking it as R1. This I am taking it as R2, and this I am taking it as R3. R1, R2, R3. All these three are parallel. So what is the effective resistance? R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1 plus R3, R1. So that is the effective resistance which we considered. Rp is equal to R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1. By taking this formula, it's very clear that instead of arranging 10 ohm, 5 ohm and 25 ohm, we will get directly Rp. So I'm replacing this equation. I am replacing this circuit like this. See here. So anyway, positive terminal and negative terminal, right? So in the problem, the voltage, the potential of the cell is 25 volt. Okay, so now I mentioned like that. So here also I'm taking the 25 volt. There is no change in that. And then 10 ohm is in series to the cell. 10 ohm is a series to the cell. Instead of 10 ohm, 5 ohm and 25 ohm. Instead of this circuit, I'm replacing with this value. Rp. Why? Because the equivalent resistance of R1, R2 and R3 which are in parallel combination is Rp. So I'm mentioning like this. Rp. Okay, now what is the total resistance in the circuit? To this, see here, the current is passing, I is the current, is passing like this. The current is passing like this. It means there is no deviation in the circuit. Started from the positive terminal and ended at a negative terminal. Okay, the same current is considered, that is I only. So now equivalent resistance R equivalent. This Rp and 10 ohm both are in series. So I am taking it as Rp plus 10, that is the equivalent resistance. Now the question is here, what is the current passing through the circuit? That is the question. What is the question over here? What is the current passing through the circuit? So according to Ohm's law, here we are taking that V is equal to IR, then I is equal to V by R. Here R is nothing but we used to represent it as R equivalent. What is the V? Potential difference 25 by R equivalent. R equivalent. That value is here. That value is 12.94. 12.94. So this is Rp. If you calculated this value, R1, R2, R3 values, if you substitute here, then that value you will get it as 2.94 ohm. 2.94 ohm. Okay, so this is 2.94. So both are in series. So 10 plus 2.4, that is 12.94, and thereby you will get the current as I is equal to what's the value, ma? To 2, that is 1.93 ampere. This is the current passing through the circuit. Got it? So very simple. So up to here, to the cell, whatever the resistor is connected, that is in series to the cell. Then from here, the remaining part of the circuit is considered. This 10 ohm and 5 ohm, both are seems to be parallel straight away. But from here, we are taking further downwards here to these two resistors. The remaining combination is in parallel. Okay, that's why 5 ohm and 20 ohm, these two are in series. So 10, 5 and 20 plus 5, 25, all the three are in parallel combination. And thereby we consider this consideration. And finally, we got the current as 1.93 amperes. Got it, ma? Okay. Now, another circuit here. 24 volts cell is connected to this circuit, and this is 8 ohm and this is 12 ohm. And this 8 ohm I am taking it as R1, this 12 ohm I am taking it as R2. Here we need to calculate the current passing through the circuit. I value we need to calculate. I is equal to question mark. Now how these two resistors are, that we need to consider. I is equal to question mark in this. Okay, now you consider it as this is the positive terminal and this is the negative terminal. This is the first end and it is the second end. This is the first one and it is the second end. And this is the, now observe carefully. The first end of the 8 ohm resistor is connected to the, for example, this is the first end and it is the second end. First end of the 8 ohm resistor is connected to the second end of the 12 ohm resistor. Observe carefully. This is the wire connected here. From 1 to 2. From here to here, one wire is connected. This is the connecting wire. Now, the first end of the 8 ohm resistor is connected to the second end of the 12 ohm resistor. Now, observe carefully, ma. That I am mentioning like this. See here. And this is 8 ohm. 8 ohm. And first end. And it is the second end. Listen, ma. Second end of the 12 ohm resistor is connected to the first end of the 8 ohm resistor. So here I am taking the resistance like this. To the first end of the 8 ohm resistor, second end of the 12 ohm. So here I am mentioning second end. To the second end of the 8 ohm resistor connected to the first end of the 12 ohm resistor. 1. So like this I connected. After that, the 1 and 2. First end of the 8 ohm resistor, second end of the 12 ohm resistor connected to the battery positive terminal. Battery positive terminal. And second end of the 12 ohm resistor. See here, second end of the 8 ohm resistor and first end of the 12 ohm resistor is connected to the battery negative terminal. It means what? It means what? Here 8 ohm and 12 ohm both are in parallel. Okay, so now with that equivalent resistance, R equivalent is equal to, if the two resistors are in parallel combination, then R equivalent is equal to R1 R2 by R1 plus R2. So this is the potential here, 24 volts. 24 volts. Okay, now here I is equal to, current I is equal to V by R equivalent. V by R equivalent. What is the V? 24 R equivalent. And that R equivalent is nothing but 8 into 24 by 8 plus 24. Then that value is here 8 into 24 by 8 plus 24. And that value is 4.8 ohm. If you calculate this value is 4.8 ohm. If you mention here 4.8 ohm as R equivalent, then current in the circuit is and that is 5 ampere. Very simple. These two are parallel. So calculate equivalent resistance at first. After calculating the equivalent resistance of the circuit, then use the formula Ohm's law. V is equal to IR. From that, I is equal to V by R. Here R equivalent, and finally we got like that. Then another